All right, hello everyone. Today we're going to just be adding a little bit to what we talked about in class. We're talking about two-way frequency or contingency tables and how to represent two categorical variables and make some comparisons and maybe some determinations about whether or not there might be an association between variables. And we're going to kind of continue that discussion a little bit today, but most of this time for this asynchronous lesson will be a chance to do some practice, okay? Please make sure you have set up your notebook because we're going to be adding a few things in there. Some of what I'm pulling from is also in your textbook. If you want to go find those things, you can find them in your textbook as well. First, as an announcement reminder, please, if you need a calculator for this year, we're going to start using them like almost every single day. So you need to reach out to me to schedule a time to pick them up. I had times last week. Not everyone came by. You will need a calculator starting at the end of this week into next week. So please make sure you come by and do that. Email or text me for times when you can come do that. All right. So really what we're exploring this unit is several big questions. And the questions can kind of be narrowed down to some more, I don't know, specific examples like this. Does the fact that the number of shark attacks increases with ice cream sales necessarily mean that ice cream sales cause shark attacks? How might you represent incomes of individuals with and without a college degree to help describe similarities and or differences between the two groups? And you might already start to have seen sort of how these kinds of questions are playing into what we already have started to look at. These two will really be the focus of what we're doing over the next little bit of time, and then we're going to start roping in this third question. How can we determine the effectiveness of a linear model that uses the number of cricket chirps per minute to predict temperature, or linear models to predict things in general? So this is kind of the direction we're going with our statistical understanding during this unit. All right. Remember this table of data looking at the relationship between snowmobile owners and environmental club membership? It's the same table of data we were using in class, but I want to sort of maybe think about this a different way. We did a lot of different work with this, finding joint relative frequencies, conditional frequencies, marginal frequencies, all sorts of things. I guess relative frequencies for those things. And then even doing or looking at like segmented bar charts to do some quick visual comparisons of some of those relative frequencies to make determinations about whether or not there were possible associations between some of these variables. I want to dig into that a little bit more. There are actually kind of three common types of representations for these relationships between two categorical variables. These are all essentially types of bar graph for which one categorical variable is broken down by categories of another. So we have sort of the classic side-by-side bar graph, where for each of our membership categories, no and yes, we identify the percent or the frequency with which people own, rent, or never use snowmobiles. And this can be useful. We can kind of tell real quick here that, oh, maybe it does kind of look like there is a relationship or an association maybe between environmental club membership and never using a snowmobile. Because I can tell that the relative frequency over here, about 70%, is much higher than the 35, 38% of the never category for our non-environmental club members. This is an example of a side-by-side bar graph, okay? And in your notes, I would just say doing some quick sketches of what each of these things look like and some quick notes about what I'm saying is really all. You need to be able to recognize them and be able to make some quick comparisons with them. All right. Segmented bar graphs is actually what we did in class. Here is the same information, really, for our environmental club membership, no versus yes. But this time, in our no category, we're figuring out, of those people, what percentage of them never rent or own snowmobiles. So notice it adds up to 100%. We can really quickly tell within each of these categories what is the relative frequency within each category. And again, we can maybe make it that there seems to be an association between environmental club membership and never using a snowmobile. All right. We might even go so far as to say there is a relationship or an association between environmental club membership and renting a snowmobile, since there is a considerably larger proportion of non-club members who do rent snowmobiles. And the most complicated of these, but also, depending on the situation, a relatively useful kind of representation is what's called a mosaic plot. A mosaic plot is essentially a segmented bar graph Notice they look very similar, except that the width of each rectangle, so going across here, the width of each rectangle is proportional to the number of individuals within that specific category. So notice the no category width is much larger than the yes category width. That is because, if we go up here to our no's, there are a lot more people in the no category than in the yes category for environmental club membership. So our no category rectangle width is going to be proportional to the number of individuals actually in that category. So it's much wider than the yes category. That indicates that there's more people in this category. So a mosaic graph actually tells us stuff about not only the quantity, there's more people in the no category, but also the relative frequencies within each of those categories. And yet again, we could do our association sort of claim here that it seems like there is an association between environmental club membership and not owning or never using a snowmobile. All right. So 3 to be on the lookout for and how we interpret those. Again, the width down here indicates that the number of people in the no category proportionally is much greater than the number of people in the yes category for environmental club membership of those sampled. All right. Now, quick reminder, when we're talking about association, we say there's an association between two variables if knowing the value of one variable helps predict the value of the other. There's an association between two variables if knowing the value of one variable helps us predict the value of the other. So for example, up here, based off of these charts, if I knew that you belonged to an environmental club and were attending Yellowstone National Park during the winter, I might be able to predict that you never use a snowmobile. Just based off of this association, I might be able to make that claim that I can predict that you never use a snowmobile, or at least never use one or rent one, and you hardly ever own one. Because it seems like just knowing the environmental club status of people, I might have a pretty good guess as to whether or not they never rent or own a snowmobile. So that's the purpose of an association. But an association does not imply causation. I can't say because you're an environmental club, you never own a snowmobile. We'd have to dig deeper into this to figure out if there's some sort of causation. Now, to close out here, I want to sort of walk through 3 examples just to help flex some of these skills. Let's say we have this table here. It's a survey of 57 students. I want to write some things down here. It's good to annotate as we go, so I want to model that for you. We have 57 students who, a survey was conducted of 57 students to determine whether or not they held jobs outside of school. The two-way table above shows the number of students by employment status, job or no job, in class junior, seniors. Which of the following best describes the relationship between employment status and class? So it looks like here we're interested in the relationship between employment status and class. All right. A says there appears to be no association since the same number of juniors and seniors have jobs. Oh, look at this. Actually, that is true. The same number of juniors and seniors have jobs. That number is correct. But if we're interested in associations, we really are more interested in relative frequencies. So let's actually go ahead and figure out some stuff. I want to figure out my juniors with jobs. I'm going to say J with J. My juniors without jobs. My seniors with jobs. I'll give myself some more space there. My seniors with jobs. And I'm going to do these as relative frequencies. Seniors with jobs and my seniors without jobs. So let me go ahead and do that. My juniors with jobs is going to be, juniors is 13. There's 13 juniors with jobs out of a total of 18 juniors. So 13 out of 18. Which is going to give me 0.7 or 72.22%. For my juniors without jobs, that'll be 5 out of 18. This category over here is going to be 27.78%. My seniors with jobs, there's 13 out of 39. So 13 out of 39 is going to lead me to, actually make this an arrow since it's not equal, we're going to do percents here, 33.33%. And my seniors without jobs, 26 out of 39. it's going to give me 66.67%. All right. So now that I have these in percents, I can do some pretty quick comparisons. Wow, it looks like by percentage, there's a lot more juniors who have jobs. So A says there appears to be no association since the same number of juniors and seniors have jobs. That is false. It looks like our juniors, knowing the class, if we knew they were juniors, we could better predict that they probably had a job actually. There appears to be no association since close to half the students have jobs. That also that won't be the answer for us because we want to figure out if there's a relationship between employment status and class. We actually don't care about the total number of students that half of them have jobs or whatever. There appears to be an association since there are more seniors than juniors in the survey. Well, that more seniors than juniors in the survey actually doesn't help us figure out the relationship between employment status and class. We don't care that there's more seniors in the survey. There appears to be an association since the proportion of juniors having jobs is much larger than the proportion of seniors having jobs. That sounds about right. The proportion, which would be 0.722222, of juniors having jobs is much greater than the 0.333333 seniors who have jobs. E says a measure of association cannot be determined from these data. We can at least estimate an association here. So the takeaways here, if we're interested in associations from two-way tables, find proportions or percents. All right, and make sure we're finding it cutting by the category, by the distribution we want. We wanted to figure out if there was a relationship between job status, so how many had the job or not, divided by the total within that class. All right. Next one. Ooh, a little longer. A director of a technical school was curious about whether there was a relationship, between students who complete one of the school's most popular health sciences certificate programs and whether those students go on to complete more advanced studies in health sciences within 2 years of completing the certificate program. She randomly selected 100 students who completed the program. Data collected on these students are shown below. All right, which of the following statements is true for these 100 students? All right. Again, we have whether they completed the most popular health science program, whether they completed more advanced studies. A says, being a person who completed more advanced studies is more likely than being a person who did not complete more advanced studies. So let's figure out each of these things that they want. Being a person who completed advanced studies. So how many people completed advanced studies? 40. So if I do the complete category is 40 out of 100 in comparison to did not complete, which would be 60 out of 100. So is being a person who completed more advanced studies more likely? No, only 40%. Being a person who completed the program is less likely than the person who did not complete the program. So how many completed the program? 60 total completed the program. Has completed the program? Yes. There were 60 total. So I'm going to say CP, how many completed the program? 60 out of 100 in comparison to 40 out of 100 that did not complete the program. So is being a person who completed the program less likely than the person who did not complete the program? No, there were 60 people who completed versus 40 people out of 100. So it is actually not less likely that you did not. It's not less likely that you completed the program. Being a person who completed the program and completed more advanced studies is less likely than a person who did not complete the program and did not complete more advanced studies. Cool, we got a lot of language here. Being a person who completed, we go to that, person who completed the program and completed more advanced studies. That's 35. That's 35 out of 100. Is less likely than being a person who did not complete the program, so did not, and did not complete more advanced studies. So no and no category. Oh, that's also 35 out of 100. So is it less likely? No, they're actually the same likelihood based off of our sample group. Being a person who did not complete the program, but completed more advanced studies. Okay, let me change color here. Being a person who did not complete the program, but completed more advanced studies. So no, but yes. How many was that? That's 5 out of 100. Being a person who did not complete the program but completed more advanced studies is less likely than being a person who completed the program, so yes, and completed more advanced studies. So that's the yes and yes category again. 35 out of 100 completed the program and completed advanced study. So being a person who did not complete the not but completed more advanced study is less likely. Oh, that is true. It is less likely. So we have D there. E says being a person who completed the program but did not complete more advanced studies is more likely than a person who did not complete the program and did not complete more advanced studies. So if we wanted that, I can do that in a different color. Being a person who completed the program but did not complete more advanced studies. So that's a yes, no category. 25 out of 100 is more likely than being a person who did not complete the program, so no, and did not complete more advanced studies. So that's the no and no. So that'd be 35 out of 100. And they're saying, is that first thing more likely? No, it is not more likely. 25 out of 100 is less likely than 35 out of 100. So what's our key takeaway here? Sometimes we actually have to do a fair amount of work. We need to actually calculate. So you should actually calculate the frequency or the relative frequency requested. Don't just eyeball it. We actually need to go through that process. If it helps, do what I just did here. Call things the yes-no category, the no-yes category, things like that. But write out each of the things to actually make your comparison. Calculate the relative frequency requested, okay? Actually do that work. All right, and finally, let's take a look. The following bar chart displays the relative frequency, so relative frequency here, of responses of students by grade level when asked, do you volunteer in community service activity? So relative frequency of different grade levels, do you participate or volunteer in a community service activity? There we go. And try to fit it all on there. They ask us, which of the following statements is not supported by the bar graph? Which of the following statements is not? We got to pay attention. Not supported by the bar graph. A says more than 60% of both 10th and 11th grade responded yes. 10th and 11th grade greater than 0.6, so that is true. We're looking for the false. So that's out. Because the percentage here is greater than the 60% line. Percentage of kids who said yes. 12th grade students had the least percentage of students respond yes. That seems true. The black section of the 12th grade is the smallest, so it has the least percentage. 12th grade has the least percentage, that's true. Less than 40% of 10th grade students responded no. Okay, we go to 10th grade students. Less than 40% responded no. That's going to be true because if over 60, this looks like over 70% of them said yes, so less than 30 said no. The number of 10th grade students who responded yes was greater than the number of 9th grade students, who responded yes. Well, what's interesting here is this is talking about number. Do we know anything about numbers here? No. We only know relative frequency. So this actually cannot be supported by the bar chart. Bar chart here, this is only measuring relative frequencies. We don't know anything about numbers. E says the percentage of 11th grade students who responded no, percentage of 11th grade students who responded no, was less than the percentage of 9th grade students who responded no. That is true. My gray section for 11th grade students is smaller than my gray section for 9th grade students. So that is true. My correct answer here is D again. So the key takeaway here is read carefully. Oftentimes you'll get questions that will make you have to remember there is a difference between relative frequency and number. All right. These three I know I'm at school and the bell just rang. I know these three questions, I didn't expect you to copy them down, but the important ideas you should have down. Do what you can to make yourself a note to internalize what we just did here. You always can have these slides to come back to and take a look and practice and check your notes against them. But at least write down what the answers were and what our big takeaways were. All right. To close out, for the rest of the time for asynchronous work, please complete the textbook problems on page 26. They start on page 26, numbers 26, 27, 29, and 31. 4 of them to do. Then check your answers against mine. My answers will be up sometime Monday afternoon. So you should do the work, check your answers against mine, and then upload your corrected work to the lesson 2.2 required homework assignment. All right? I'll see everyone later. Please make sure that you reach out to me if you do have questions. Bye.